Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Securing JavaScript and Go Code with Insights and Analytics. Our speaker today is Pritam Jinka, who is staff engineer at Shift Left. Pritam, thank you so much for joining me today. I appreciate it.
Thanks, Charlene. And thanks everyone for joining. I'm really excited to talk to you about securing JavaScript and Go code. So the agenda for this webinar is, first, I'm going to give you just a brief overview of a typical JavaScript and Go workflow. So I'm a developer at Shift Left, and I'll just talk a little bit about how we like to develop our Go and JavaScript code. And then I'll talk about how we introduce security into that sort of environment. After that, I'll jump into a bit more detail about security, talking about static code analysis. And I'll also give you a couple of demos using actual JavaScript and Go projects. And then after that, we'll go beyond just individual security issues and talk about how high frequency code scanning can give you insights and analytics with trends. And then finally, we'll wrap it up with a Q&A. So let's briefly talk about what a typical developer workflow looks like in a modern DevOps style CI/CD environment. So usually, whenever we look at a project, there's typically some sort of main branch that we're dealing with. This could be called master or main. In some organizations, it's called dev. And this is typically the branch that is basically ready to go out to staging or production, is free of any security issues or any bugs. Basically, the final result of any development work or bug fixes. But on a day-to-day basis, a developer like myself is not going to be working directly against that main branch. What we do is we create a fork off of that branch into a development branch or a feature branch, and then we make our changes in our own branch, and then push them up as we finish committing code. And then after that, once all the development work is done and all the checks are complete, then we merge that back into the main branch. So that process of pushing code and running checks is what I want to dig into a little bit more. So if you have a CI/CD environment like Jenkins or Circle CI or GitHub Actions, this is the environment where you're actually running a bunch of comprehensive tools against your code. So tools like linting and formatters, actually building and compiling the entire code to make sure you don't have any syntax errors. And finally, this is where you're running comprehensive unit tests. So if this is the environment where you have tools that are scanning your code, it makes a lot of sense to introduce, a security solution that's going to take a deep analysis of your code. This is the sort of natural place to do security scanning. So I'm going to go a little further and say, not only is that the best place, a convenient place to do security scanning, I'm going to say it's actually a requirement that you have security scanning integrated into that sort of developer workflow. And the reason is, if security is not integrated into that sort of workflow, then problems aren't fixed as soon as they're introduced. Security issues won't be detected early. If you're not scanning on every push or pull request, that means you're scanning for security issues way down the line. Maybe at release time, maybe, every few weeks or so, way after the vulnerabilities are first introduced. So that means security issues aren't detected early, and as more time goes by, the more likely it is that vulnerabilities are more deeply integrated into a code base. People build on top of that code that you checked in with vulnerabilities previously. And the more deeply integrated these things are into a code base, the more difficult they are to change. And this isn't just the case for security issues. Consider like any bug. Every developer eventually finds out how annoying it is to fix bugs months after they're introduced or in legacy code. It's worse when bugs are so old that no one is familiar with the code base anymore. So if you're going to secure Go and JavaScript code, the best place to do it is on every pull request. So now I just wanted to give you a quick demo of two small projects that we've made purposefully with a bunch of security vulnerabilities. So here's a here's a Go project. It's called the Go Vulnerable Web Application, and it has lots of different kinds of security vulnerabilities built into it. Now, what I'm going to do is I'm going to make a quick pull request, sort of demoing the developer workflow I talked about earlier. So I have a file here that I've worked on before, so let me just open this up. So here's a Go source code file, and I see a log line here. So let's say I'm debugging something, and I'm going to uncomment this log line. So what I'll do is I'll go ahead and edit this file, and I'll uncomment this, and I'll make a new pull request on a new branch, just like I talked about earlier. Now, when I make this pull request, what's going to happen is a new GitHub action is going to be launched that's going to do my security scanning. Now, before we dig into what's happening here, I just want to give you a quick background on what that security scan means. So what's happening in the background is I have shift left running a code analysis scan on my source code. So what that's doing is it's taking my source code and turning it into a structured representation called a code property graph. So this graph is similar to what a compiler does when it compiles your source code. But instead of compiling it to an executable format, shift left is generating a code property graph, which is a combination of the abstract syntax tree, the control flow graph, and the program data flow graph. And it's building this graph so that it can run queries to identify security vulnerabilities. So the line I just commented out was a log line. And if we jump back into the code, so you might not realize it, but that change is actually introducing a sensitive data leak. And I know that because, it's just a simple log line, but it's printing out a phone number, a name, and the city of some profile. So it's actually logging sensitive data. And static code analysis is able to recognize that because it sees that there's sensitive data called phone number. It's a sensitive variable that's eventually going out to this internal function called log.println. So it knows that there's a sensitive variable that's being logged. So if I jump back into the pull request here, we see that the static code analysis has already finished. So this is really fast, it took only about a minute. And if I jump into the results, I see that there's one new finding that I've introduced, and it's that sensitive data leak. So there's, some sensitive data that's being created in a function called new profile, and eventually it's ending up in a print line. But as a developer, I don't have to be aware of that on every pull request. I can just, write my code as necessary, and just like any other build tool, this is going to alert me if there's some sort of error in my code. So similarly, here's a JavaScript code base. And what I can do is go into some sort of file here. And instead of introducing a vulnerability, what I can do is can find some sensitive data leak that seems obvious here, like some credit card information being logged, and I can comment that out and do the same thing. I can create a pull request and launch the security scan. So now what I want to do is quickly just go over how this works. If I jump into the GitHub action configuration, it's really, really simple. So we have some setup jobs here that go on, but scanning code is, pretty much as trivial as one line that runs an analysis. So there's, some boilerplate here that tells, the name of the app and setting the branch tag and the language. But besides that, it's a lot like, a linter or something, where you just point the location of your code and it does a scan. And similarly, the Go version is pretty much the same code, except the application name is different and the language is different. So what I've just demonstrated is how easy it is to start scanning Go and JavaScript code. There's not really much going on. It's pretty much adding one line in your CI/CD environment that initiates a scan. And it's pretty much, like any other linter or code formatter that you're used to. So what we see with our customers is that, as soon as they introduce security scanning into their pull request workflows, we're seeing that their scanning frequency is orders of magnitude higher than what they're used to. A lot of the legacy tools and vendors that they were using previously, maybe we're only scanning only at release time. Maybe there were manual scans, or they were scanning infrequently, like maybe just every month or only a few times a year. But today's DevOps and security standards are moving away from those sorts of infrequent scans and moving towards scanning code on every pull request or every push. And with really high frequency code scanning comes insights. So once you go beyond, fixing individual vulnerabilities, and basically learning not to use certain library functions, or sanitizing your code, you can, once you have high frequency data, you can start looking at trends and go beyond just looking at individual vulnerabilities and start thinking high level. You can start thinking about things like, which applications are responsible for the most security findings? And are the number of critical vulnerabilities increasing or decreasing over time? These aren't questions that maybe a developer is interested in, but managers are probably interested in this, and security teams that aren't looking at individual pull requests or individual applications, but rather, dozens of applications or hundreds of microservices. It's really valuable for them to start thinking at a higher level beyond, individual vulnerabilities that, a developer might be interested in. So what I wanted to show you now is another demo, except this time we're not going to go into GitHub. I'll show you the shift left UI. And what I've been doing with this Go and JavaScript demo is I've been running scans on a daily basis for the last few days just to simulate, a developer that's working on a code base on a daily basis. So let me go ahead and open these up. Okay, so what we're seeing here is two repositories with daily scans, and you can just see that clearly from the trend chart that the number of vulnerabilities in the Go application, for example, first decreased and then increased over time. So if I just focus on the Go application, I can see that, let's say, starting from the beginning of the month to today, I've introduced 6 new vulnerabilities and fixed 2 of them. But the important thing is, not just that the total number of vulnerabilities or findings has gone up 29%, but actually the number of critical vulnerabilities has tripled. It went from 2 to 6. So that's probably, as a security engineer, that's probably what I want to focus on. And if I jump back and add another application, the JavaScript application is actually doing a lot better. The number of findings actually went down. So as a security engineer or manager, I might be interested in taking a look at this every week or every month, and maybe I want to report some of these metrics to another higher up. A convenient way to do that is to export this as an executive summary, or you can customize it by only focusing on the critical vulnerabilities or certain types of vulnerabilities or other findings like secrets or insights. So now that I've talked about where we can go from high frequency security scans, let's talk about what comes after that. So now that you have reports and stuff, how can you actually address some of those issues? What if the number of critical vulnerabilities is going up? What if the number of total findings in all of your applications is going up? How do you actually address these issues? This is going beyond just fixing all of the issues that may exist now, but what happens in the future? What if the trends don't go down over time? Well, I have 2 approaches. So the first is called build rules. So similarly to how a linter might fail your pull request, or if you have a typo and your code doesn't compile, it breaks the build, you can introduce these concepts into security rules too. So what I'll show you is an example of a build rule. So this is something you can add into your pull request workflow, where you can customize a policy that says if the number of security vulnerabilities of a certain type is beyond some threshold, then I want to fail the build and not allow a merge back into the main branch. And this way, And this is actually enforcing the policy of not introducing any new vulnerabilities into your main branch. This is going beyond just highlighting security issues. It doesn't, without build rules, you can't actually prevent new vulnerabilities from being introduced. But once you start using build rules, this makes the developer take action and actually fix the vulnerability before it's actually introduced into your code base. So if I go back into the demo, I can show you an example of a build rule. Again, it's just an additional step in the workflow here. So the first step was to actually scan the code, and then you can run a build rule against it. And the build rule, you can define with just a config file. So in this case, I have a build rule that says, don't allow any findings. So this is checking for vulnerabilities and secrets and security insights, and checking for all severities. So it's allowing absolutely no finding, no security issues to go through. And if I jump back into the pull request here, I notice that it's failed. It's failed at the build rule step. So if I jump into the details, you can see that it failed my build rule that said allow 0 findings because there are 19 vulnerabilities that matched, and my threshold is 0. Now, if I had a policy set up for this repository to prevent a merge, then I wouldn't be able to merge this pull request. So that's one approach. The second approach, it doesn't have to do with any configuration. It's actually more about developer education and training developers to recognize security issues as they write them, or just informing them about secure coding practices. So I think for a lot of organizations, they might not have a formal training policy to teach them how to write secure code. I know from my background, I'm a mostly self-taught programmer. I never had formal training to develop secure code, but the organizations that I've worked at have rolled out security training programs, and that's how I learned about the OWASP top 10. So going back to the security trends, you can probably, if you're seeing an increase in security vulnerabilities, you can try training your developers about the OWASP top 10 and other secure coding principles, and then see if that actually results in a reduction of security vulnerabilities over time. So what's next after this? I think high frequency code scanning and security scanning is a brand new trend. We're seeing more and more, this is kind of a new thing for developers. And as we start embracing this practice more, we'll start to see more and more opportunities to build more analytics on top of these high frequency code scanning results. So what does that mean? That could mean, we can start paying attention to things like, specific types of vulnerabilities that are trending over time, the mean time to resolution for vulnerabilities, metrics that, higher level metrics that you might not have even considered before you had high frequency code scanning. And that's all I had. And of course, if you wanted to try any of this on your own, whether it's for your own Go and JavaScript code bases or the same demo apps that I've used, you can go to shiftleft.io/register and make a free account. And then you'll be presented with a way to add your GitHub account, and it'll fork the demo apps for you automatically.
All right, great. Why don't we go ahead and open things up for question and answer now. If you have a question, please go ahead and use your GoToWebinar control panel and submit it. And we'll go ahead and get started with what we have so far. Let's see, here's the first question. Are you doing grep, like analysis and looking for patterns?
Nope, as I mentioned early in the slides, we're doing something called building a code property graph. So this builds a structured representation of your code, and then we use that to query for security vulnerabilities. So it's a bit more extensive than grep because we're also doing data flow analysis and stuff like that.
All right, great. Next question. Let's see, how do you use NPM packages in the most secure way in our code, or how do we use NPM packages in the most secure way in our code?
I think one way is to use what's called software composition analysis. That's not something I've demoed, but if you use something that's actually looking at the packages that you're using and then looking at publicly available CVEs and comparing those and making sure you're not using vulnerable packages, that's probably one way of using NPM packages securely. The other thing is that if you even if there aren't CVEs, you could be using an NPM package improperly, like if you're using like a specific logging library or something and you have sensitive data going out to the log, that's probably something a static analysis tool can catch.
All right, great. Next question, how do you identify sensitive information versus non-sensitive information?
That's a good question. So in shift left, the way we identify sensitive information is we have what's called a sensitive data dictionary. So these are keywords and patterns that are typically used for sensitive or variables that hold sensitive information. So for example, CCNum, could be a variable that holds credit card numbers, but that's customizable. For your organization, you might have a different set of naming conventions, but that's just how we identify sensitive information.
Okay, all right, great. Next question, how can I export the list of vulnerabilities?
So in the UI, there's the export button that I showed. And let me just quickly demo that. So here's a HTML version, and here are all the vulnerabilities that I have exported.
Cool. All right, next question. Let's see. Does shift left have features to identify and notify for any PHI protected health information data in logs?
Yes, our sensitive data dictionary does have some patterns that recognize those, but that's that's probably a good follow-up. So if you contact us, we can dig into that a little bit more.
Okay, all right, great. Guys, plenty of time for question and answer. If you have a question for Pritam, go ahead and use your GoToWebinar control panel. Next question here, is there a way to ignore certain vulnerabilities from my scans?
Yes, that's a good question. So if I jump into one of the vulnerabilities list here, so if I think that one of these is not an issue, I can just select it and hit ignore.
Nice. All right. Okay, next question here. With regards to the keywords to identify sensitive information, are there dictionaries for foreign languages? Say, for example, password German versus password. Are you using Levenstein distances?
About the languages, I believe I'd have to get back to you on that. I mean, you can extend the dictionary with your own keywords and patterns. Whether it works for non-ASCII characters, I'm not sure. But yeah, reach out to us and we can answer that specifically.
All right, great. Okay. All right, let's see. So many great questions that are coming. Do I have to send my source code to your servers?
No, you don't. So the only data that reaches out to our APIs is the code property graph, which is not source code. It's just high-level metadata.
All right. All right, here's a good one that just came in. From what I understood, you scan for OWASP recognized threats. Is this updated frequently? And can I rerun analysis on my code?
I don't think we just recognize OWASP recognized threats. We just categorize the vulnerabilities as OWASP, but the policies can be extended to any type of vulnerability. And what was the rest of the updated question?
Is it updated frequently? And can I rerun analysis on my code?
Oh, yes. Yes, you can rerun analysis just by rerunning SL analyze again, whether from your CI/CD environment or just manually. And we do update our security policies. At this point, it might be several times a day or something. So the benefit of using, software as a service security scanning is that our security information and policies are updated continuously, and you inherit that automatically.
Okay. All right. All right, we've got a couple more questions here, but there's plenty of time. If you have a question for Pritam, please go ahead and use your GoToWebinar control panel. Can't believe the questions we've gotten in so far. They've been really, really great. Okay, here's one for you. I've tried other SaaS vendors and got a bunch of false positives. How good is your analysis?
We think it's much better than competitors. In fact, on our website, we have the results of the OWASP benchmark, which is one of the top benchmarks used by all of the different vendors. And I believe we had the best true positive rate, which means finding actual vulnerabilities, and then the lowest false positive rate, which means we're not finding unrelated issues as security issues.
All right, great. Next question, is there any limitation on the scan tool?
Yes, so for the free tier, there are certain limitations that I can't remember off the top of my head, but they're on the website.
Okay, all right, great. So yeah, you can always go look at shiftleft.io and take a look at the different tiers there. Also, if you want to try it out on your own, that is a good one for those who did submit a question regarding giving it a try before they buy. So, all right, I have one more question in here, and then I guess I'll close out the question and answer period if we don't get any more in. But how is your analysis different from other vendors?
That's a good question. So this might be a little technical, but one of the approaches that we take is we use a single data structure for building the structured representation of the code. So we have the code property graph, and it's a combination of different data structures, which means it uses less resources, and that's what makes us faster.
All right, great. All right, well, though, as I said, well, actually, did get one more in. Do you have support for Rust?
Not right now.
Okay. All right, is that a roadmap thing, maybe?
Yeah.
Okay.
I'm not sure how prioritized it is, but yeah.
Okay. All right, great. Well, that is all the questions that we've gotten in so far. I'll leave the question and answer period open for a little bit just to see if we get any stragglers in for you. But while we are waiting, just a quick reminder that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, see the demo in action, you will have the opportunity to do so. We will be sending out an email that contains a link to access the webinar following today's webinar, and you'll be able to see it on demand. The webinar is also going to be on the Security Boulevard website, so you can always go look for it there. You can just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I'm not seeing any other questions come in, so at this point I'm going to go ahead and close out the question and answer period. If you do have a last-minute question, still go ahead and use your GoToWebinar control panel, as the folks at Shift Left are going to be getting a copy of all of the questions that came in, and I am sure that they'll be more than happy to follow up with you offline to get your question answered. So feel free to just at any time just use that GoToWebinar control panel and submit your question. Let's see, at the top of the hour, I did mention that we would be doing a drawing for 4 $25 Amazon gift cards. So let's go ahead and do that real quick. Our first winner today is Dave S. Congratulations, Dave. Second winner is Tom L. Congratulations, Tom. Third winner is Marcus M. Congratulations, Marcus. And our fourth and final winner is Carrie K. Congratulations, Carrie. We'll be following up with all 4 of you by email to get your Amazon gift card over to you. So check your inbox, and if you don't see anything in your inbox, please check your spam folder. All right, Pritam, it looks like this is the end of the webinar. Thank you so much for your insight. Thanks for showing us the demo. I always love the demos. I'm a big fan of the demos. So thanks very much. Great presentation overall. Really appreciate it.
Yep, thank you.
All right. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.